together by a joint powers of authorities out there.
Talking compost here. You want to do a little introduction to where we're at here?
Yep, we're at the Inland Empire Regional Composting Facility in Rancho Cucamonga, California. This project is a joint project between two water districts, Inland Empire Utilities Agency and Los Angeles County Sanitation Districts. The project was put together to manage biosolids and green waste from the Southern California region. It's been in operation since 2007, and we currently process about 200,000 tons of waste products into compost every year.
Wow.
So we're going to drive through the facility just like material goes through. Trucks are directed to go to one of these doors, and what they do is they back up and enter these doors, and there's a metallic loop on the ground, and when they drive over that, it triggers the door to go open, and you can see the doors are all bowed in, and that's because this whole building is on negative air. And the uniqueness about this facility is that the entire process from receiving material to composting material to screening to loading trucks, all the quality control, the batching, everything is done inside a containment of the building. And so in order to meet the air standards for Los Angeles, we're in the South Coast Air Quality Management District, all this is contained. So all of the emissions from the composting process are contained within the building, exhausted out of the building, and sent through a biofilter. And so that's why the doors are bowed in, is because the entire building is on negative air. So to demonstrate that, you can light a smoke bomb and send smoke wafting around the parking lot, and you zip open the door, and the smoke whooshes in, and then a little while later it'll make it out to the biofilter.
Wow, here it is like a cavern. Wow.
This was a IKEA warehouse. It was converted.
Wow.
For this facility.
This is incredible.
Yeah. So every day about 35 trucks come in, unload their material, and there's two major types of material. There's wood waste, which comes a lot from horse bedding, and also from chipped up trees and different things like that. So we take in material that meets our specifications for carbon and particle size, things like that. And then biosolids are dropped into their own hoppers, and then a loader operator, this guy right here, is controlling which hopper starts, and then all of this material is metered into a mixer. It's blended and then sent by conveyor into an active composting area.
Wow. This is cool. We're gonna follow him in?
Yeah.
Cool.
So all the material is unloaded in this room. It's mixed together, blended, mixed together, and sent by conveyor into this next room. You see we're heading uphill slightly. We're going 18 inches up, and that's because on the old warehouse floor, we put pipes and spigots and then slurry and concrete over an air system. So underneath this floor is a bunch of pipes that go to fans that we control, and we send air to the compost piles.
Oh,
so,
underneath.
as you know,
oh, cool. Of course,
biology needs oxygen.
Yep.
And so in this particular technology, we're using aerated static pile. So the compost recipe is placed on the air pipes on the floor, and there's temperature probes placed into the piles, and then the computer system monitors time and temperature, and then we control fan speed to maintain the optimum temperature. So there's a little bit of a trade-off. If the temperature is allowed to get too hot, a lot of the beneficial bacteria will die off. It's just too hot for them. If it's too cool, you're not going to kill the pathogens. So maintaining the optimal temperature using the least energy possible is sort of our job. So we're trying to make the best compost we can in the shortest time period we can, ensuring safety, compliance, and economics.
Awesome. This is pretty outstanding here. Wow.
So the brand new material that was just brought into this facility, it lands in the center of the room. And that's what that pile being built ahead of us is. And a loader operator will pick that up and build a pile. That brand new material, if you stick your hand into that pile, it's ambient. It's probably 70, 80 degrees. But if we came back 3 or 4 hours from now, you would not be able to stick your hand in that pile. It'd be 130, 140 degrees.
Yep.
And that's just the microorganisms working to break down all the organic matter. So a lot like a little compost bin in your backyard, you know, bugs are breaking this stuff down, and a byproduct of that is heat and carbon dioxide.
This is like the biggest
complex carbon.
This is like the biggest
all that.
party. We're making the biggest party for microbes on the planet.
And one of the ways that we ensure that that's kicked off is by having the right recipe of carbon and nitrogen and water and oxygen, but also we use our recycled material as an inoculum. So we mix some of that in the beginning, and that's why that stuff will kick off in just a couple hours. It's hot.
Right.
And that's because these bugs away
How much of that are you taking?
About 30 or 40. No. We just use our own material. So
how much to inoculate it? How much do you need to not?
We use about 30 or 40%. And we do that on purpose because
that makes sense.
large wood chunks, the customers don't want that.
Yeah.
The customers want the finer material, the soil-looking, nutritious material. The large wood chunks are usable for us over and over again as porosity, and it also carries the right type of bacteria. So when we recycle this stuff, it saves us truck traffic and the expense of acquiring new material, and it also kicks the stuff off and allows us to use the space more efficiently.
Awesome. Love it.
So every day we build a row, and this is a elongated block of 11 rows right next to us on the left-hand side. And so every day we build one of those rows, and the loader operators can see the markings of where rows start and stop. And then every day we take the oldest one down. And so there's 22 rows in here. So we take one down and build one every day. It's about a 3-week cycle in this room. So this is the active composting section, and it maintains at about 170 degrees for 3 weeks.
Wow.
When it gets done with this process, we send it over to curing, and at that point it cools down, it dries out, the odor becomes much better, it's less sticky, it's lightens in color, it turns into this kind of brownish.
What's the turnaround rate? What's the turnaround time?
In this room for active composting is 3 weeks, and for the whole entire process is 2 months.
Oh wow.
Yeah, so it's very, very rapid.
Incredible.
Yeah.
I try to get through here without getting hit.
Yeah.
Here we go. Wow. This is awesome. I know you guys have seen this many times, but this is incredible.
I'm just thrilled you think it's awesome.
So you can see in the brand new material there's chunks and different colored things and globs of this and globs of that, but you'll see that the very finished product doesn't look anything like that, and that's after only 2 months. Very, very consistent, very stable, and that's because of the mechanical controls we have.
So that material is being conveyed on these conveyors now to the curing room.
Yep, it's going to the next section where it's going to age. Just dry
that's
out.
the finished stuff, or the done process, the initial process.
Well, it's done with the initial process, but the customers don't want it yet. It's going to smell a little bit. It's too sticky to screen efficiently. In this section, this is a screening plant. So almost all composting facilities are going to have some sort of screening plant that's going to size the material to where it's aesthetically attractive to customers. And so in our case, we're screening down to 3/8 minus, and that looks like coffee grounds or something.
Yeah.
It's pretty fine material.
Yeah.
So there's a lot of mechanical equipment in here because screening is dusty, and we want to make sure that the environment is safe for workers. So we capture all the dust and put it through a filter system and then recycle the air back into the facility.
Oh wow. Got to make some movies in here.
Yeah.
James Bond next scene is a
Right.
compost facility.
Yeah, you can see all the steam, and that's because
Here's the pitch.
Yeah.
it's cold. It's cold outside.
Slightly promoting compost through James Bond movies.
Oh, I like that.
I like it.
Yeah.
Good idea.
We just
Yeah,
got
it'd be
Rosario
some good paintball
Dawson.
games
We
in
just
here.
got Rosario Dawson to sign on for the compost story
Awesome.
a couple days ago.
Is that
And-
everybody? Has you got everybody? in
No,
here?
we're trying to get Mark, the Hulk. What the hell's his name?
Oh.
Mark. Why am I forgetting his
I
name?
don't remember. That's awesome.
And Shailene Woodley, as well.
Is this
And
Josh Tickle's film?
no, this is the compost
your-
story.
your
This is the short. That's the next. Not the next, but
Yeah.
the addendum to the soil story.
So this
so-
guy's taking material that's been through the curing process,
Wow.
and he's putting that into a hopper that feeds the screen. I'll go ahead and pull it out of his way here. But so this
Wow.
material that is next to us is right out of the composting room. So it's going to go into
That's a
curing,
good
but
shot
that's
right there.
170, 180 degrees right now.
Wow.
That'll sit in here for a month, and then it cools down to 110, closer to ambient again.
Wow.
On the left, you can
So
find-
these are all curing right now?
Yes. So you can see the stuff, it's much cooler. If you stuck your hand in there, you're getting closer to 110, 120 degrees. It's calming down. The bacteria is starting to, slow down a little bit. It's turning back into a soil-like product. And then we take this stuff and put it through a screen, and then it'll turn into what we'll see in the next room.
Wow. And remind me again, how often you guys are turning? Are you trying to do as much static as possible?
It's all static. The only time it's manipulated is when we move it from active to curing, and then from curing to the screen, and then load a truck. So it's just to move the material from one phase to another, and by doing that, it gets agitated.
Right.
And we put in the hoppers that we feed to move it from one area to another. There's actually beater bars in there that break it up and mix it.
Right. So generally through the process, you're having pretty much static, except for moving.
Correct.
Great.
Yeah. It is absolutely. It's called aerated static.
Yep. That's the stuff.
Yep.
Wow, you guys, this is awesome.
So in this room is finished product, and trucks pull onto there's a truck scale behind that push wall over there, and it's a little bit lower to make it efficient to load the truck. And
there it is, pouring down to the ceiling, or looks like a.
Yeah.
This is so cool. Yep, rich goodness. There it is.
That's almost 2% nitrogen, about almost 2% phosphorus, and 0.5% potassium, 2.5% iron, 70% organic matter.
Wow. Are we allowed to get out here or no?
You can. You
Yeah?
want to get out? Sure.
Well, let's pull up to that pile. I'd love to touch it and get a feel for it. All right. Right. Here we go. Real deal.
I like the smell.
It smells really great. Check it out. Wow. Still a tad warm. Good. Look at that. Mounds of finished compost. It's pretty incredible. The world's largest indoor compost facility. Awesome.